Okay, so welcome to this is week 2 of statistics. And what I'm going to do is I'm going to share my desktop and kind of talk about what we're doing today. So let's do that. Okay, you should be able to see my desktop now. And let me talk about the plan today. What we're going to do is we're going to start out, as I always will, with any questions you might have. So that could be about anything. And I want to let you know, I graded the discussion posts. I'm about 40% of the way finished grading I graded the 2 truths, 1 untruth discussion post, and about 40% of the way done with the other discussion assignment. And I'll have that by the end of the day for sure. Make sure you read my comments, because that will help you not make the same mistakes that you made this time, or it'll let you know that you did everything perfect. And there were a few of you did that. One thing to note, and I want to remind you, and I'll remind you over and over again, but you need to remember Thursday is when the discussion post, initial post, is due. A lot of you are waiting until Saturday or Sunday, and then you lose points. So make sure you have it in the next few days, and you're ready right away to do that, to post it. And this one's actually on chapter 2, so you've been ready for a while. And I always post a example post, and I respond to my own example just so you can see an example. Don't respond to yourself, though. You don't want to give away the answer. You want to let your students do the answer. Can I change the dates of the assignments because they're off? If you find one that's off, post it in the Q&A, and then I'll fix it if it really is off, okay? But you have to let me know which one. Yeah, so let me know which one. Post it in the Q&A forum. That's the best place, because while I'm doing this lecture, I'm not doing that kind of stuff, but afterwards I can do that easily. But you have to let me know then, and that's the best time. And then I've got it on the Q&A, and I'll fix it if there's any mistakes. And there could be mistakes. What I do is I copy the assignments. I copy the whole course from the last time I taught it, which was in the spring. And then supposedly Canvas does an adjustment on the dates and sets it so it's all right, but Canvas isn't always right. So sorry about that. So if you find something that's wrong, I'll fix it. But you have to let me know on the Q&A board is a place to put that. Okay, so just note, and I'll be happy to do that if there's any errors, for sure. So sorry if there are any. But I'll answer any questions you might have about anything. And then we'll get into probability. So heads up, it's actually kind of an easy one to watch me do, but it's not easy to do yourself. It's one of those. I like to think of it as kickboxing. Very easy to watch someone else kickbox. Try getting in a ring by yourself and doing it. Hey, all the easiness goes away. So be aware that this is a tough week in terms of the difficulty of the questions, not because I was in a bad mood or something. Just probability is what a lot of people have trouble with. So I'll give you the definition. This actually should say, well, I win $300 million, because it changed since I typed it. There we go. So do you think I'll win $300 million? Find out. Then I know this sounds a little weird. I'll talk about and. One of the things about probability, a lot of it is to be able to read and be able to take what's shown, interpret it, see if it's talking about and, or maybe it's talking about or, and maybe it's talking about given. Those are kind of 3 main words and concepts that happen. And then based on those, there's going to be equations for probability. And that's what we're going to be doing a lot of. And then we'll have very special types of events. When you have two different events, then sometimes they're what's called mutually exclusive. I'll talk about what that means. And sometimes they're called independent. And I'll talk about what those mean. All of this is going to be pretty mathy. So you're going to be doing a lot of putting in numbers in a calculator type stuff. And then I'm going to go over project one. So project one, I think you have about 3 weeks still, over 3 weeks to do it. That doesn't mean you should wait until the very end to start. I recommend starting, very soon after this webinar. And hopefully you all have partners, because that's what I talked about last week, is you were supposed to get partners last week so that you were ready to get started this week, was a plan. Okay, so that is the idea for this webinar. So are there any questions at all about anything? While you're doing it, I got to grab something. Yep, got what I needed. Any questions? You can post it in the chat box, or you can talk and ask. Any questions? Okay, so if you come up with thoughts on questions in 20 minutes or 10 minutes or half an hour, whatever, feel comfortable to still ask, even though we're asking you now. But if you have questions as it goes, please ask questions. And then if you have questions after the webinar is over, please post in the Q&A board. For regular questions, please post on the Project One discussion board if you have project questions. So it is important. We're here for you. Brawley and I are both here for you to help you out with any questions you might have. Okay, so I have something. That's why I turned around over there. Y'all recognize what this is? Yeah, cards. Okay, and I think what I've noticed is that I think as time goes on, as the generations are changing, I think cards are played less. When I was a kid, everybody played cards like all the time. But now with the internet, you have more games to play. But still, you guys know what cards are, and they work well with probability examples because easy to kind of see. Okay, and the other thing I've got, I think it's in here. There it is. You know what this is? Yeah, that's a quarter coin. Okay, so again, someday coins will go away too because of inflation, and all we'll have dollars will be like a penny. But right now we still have coins, and I can flip a coin. And my guess is you could answer this. I just flipped a coin. What's the probability that this coin, if I flip it, is going to land on heads? See if you guys can tell me. So what's the probability that if I flip a coin, it'll land on heads, and I'm not cheating or anything like that? It's supposed to be neat. This is a very easy question. Yeah. And by the way, feel comfortable sending to everyone. It's even better. Okay, 50% is a good way of talking about percents. I just want to let you know if we're going to be doing calculations, it's better to write decimals than percents because calculators don't handle percents very well. So I'd rather talk about it as 0.5. And I want to look at it kind of specifically, even though you all understand it. It's actually 1/2. And hopefully, that's also 50%, and that's also 0.5. But I want to talk about where does a 1 come from and where does a 2 come from? So let's start out with a 2. Where does a 2 come from in this fraction? Any thoughts? Any ideas on where the 2 might come from? Yeah, there's 2 different sides of a coin, heads and tails, right? So the denominator is all the different outcomes that could happen when you flip this coin. In this case, there's just two of them. Any questions on that? Where does a 1 come from? So I'm trying to give you an example where I think everyone knew ahead of time the answer, but now I want to really focus on it. It represents a desired outcome. Maybe your idea is right, but it's actually the number of outcomes that are desired. So in this case, there's 2 full outcomes, head and tails. One of those is heads. See how that works? Okay, so similarly, I can pick a card. So I mix my cards and I picked a card. What is the probability this card right here is a spade? Any thoughts? And again, the hint is it's always best to write as a fraction. So it's the probability that it's a spade. Okay. Okay, good, good. So what you want to do again is say, well, and this is something, you know, if you don't know, I don't test you on this question is how many cards are there in a deck, but it looks like, you know, some of you knew that. There's 52 cards in a deck. So that's the denominator because there's 52 total cards that could come up if you pick a card. Of those 52 cards, 13 of them, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, 13 of them are spades. So the probability that you pick a spade is going to be 13 over 52. Any questions on these 2 examples of probability? Okay, my guess is that you didn't find this that difficult. So is probability always easy like this? Any thoughts? Yeah, not always, not usually. Just big heads up warning. But at least these 2 examples are easy. We're going to get harder as we go, where you're not going to just be able to count. So here is, let me make this a little bigger. The definition of probability. So the probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. Okay, which is, so when we did the cards, there were 13 ways that A could occur because there were 13 spades. And of those 13 ways that A could occur, there were 52 total possible things that could happen because there's 52 cards that could get picked. Okay, in symbols, the good news is mathematicians are boring. We tend to just use whatever the letter is, the first letter of whatever word you're working with. In this case, probability. So we use capital P for probability. Sometimes we use lowercase p too. Later on, in a couple of weeks, we'll use lowercase. But for this week, we use capital P. Sorry about the issue, but that's not my fault. That's what everyone uses. So P, and then you put a parenthesis, A, and parenthesis. Okay, and sometimes, as I wrote here, sometimes you'll go P, parenthesis, heads. Sometimes you'll spell out what A is, and sometimes you'll just write A if it's general. And that's always a fraction. And it's the number of events in A over the number in the entire set. Any questions at all on the probability? Doesn't look too hard, right? What do you think the hardest part of probability? What do you think the hard parts of probability will be? Any thoughts? Because I warned you this is tough. Any thoughts on what might get hard? Making sure you're not overcounting or undercounting. Okay, so one is you can make a mistake. That's definitely one. But even to get started, to get there. Okay, if I don't see your answers, I'll let you know. There's two main hard parts. One is counting. Sounds so easy, doesn't it? But we'll have lots of examples where counting is brutal. And the other is vocabulary, is understanding what A really is by reading the whole big long sentence. That tends to be the difficult part. And even understanding what the entire set is by looking at the whole sentence. So it's kind of the reading and interpreting and understanding the meaning of the sentence that you're asked. Okay, and then counting. So the next one will be counting. Okay, so now I'm going to do the following. I'm going to pick a card. And then watch, I'm going to take that card, I'm going to put it over here and drop it down. Now I'm going to pick another card. Got it? So I now pick two cards right here. What is the probability that both of these cards are kings? Okay, and this is a lot harder than just flipping a coin and saying, what's the probability of heads? Yeah, 2 out of 52 is one guess. The hint is this is hard. So if you did it easy, you made a mistake. Just let you know. So let's take a look. This is the way we're going to do it. We're going to do one at a time. What's the probability the first card is a king? Let's write that in a sentence. Probability the first card is a king. Yeah, that's just 4 out of 52. That's not so hard. Okay, unless you have no idea what cards are. But if you know what cards, you know there's 4 kings and there's 52 cards. Any questions on that? Okay, well, in order to win, and we win if there's both kings, then that means this first card was a king. Got it? So I just picked a king and I put it down on the table. I still have the rest of the cards in my hand. Now comes the interesting one. What's the probability the second card is a king? If we know the first is a king. Yeah, that's going to be 3 over 51, because if we know the first was a king, here's the good old first card. Hopefully you can all see that one. That's a king. And I put it down. There's only 3 kings left. And there's only 51 cards left. That's going to be 3 over 51. Any questions so far? Okay, so now what I'm going to do is the multiplication principle. Okay, and what that tells you is that the probability of A and B, so that means the first was a king and the second was a king. It's the only way you're going to win, right? Is the probability of A times the probability of B given that A occurred. Any questions on this idea? Okay, that's pretty tough, isn't it? So now we do it. That's going to be 4 out of 52. And then times 3 out of 51. Okay, and my guess is most of you can't do this in your head, am I right? But you're never responsible for doing it in your head. What you can do is you can just take that. Uh-oh. Let's try this again. And pop it into, I like Google. I just copy and paste it in, and it tells me exactly what it is. And it says it's 0.00452, etc. So very small chance. Okay, it's not one of those that you can just quickly do. It takes some work. And that was my warning, the heads up that this is not so easy. Any questions so far?
Hi, I just have a brief question about formatting. So let's say this is a problem. Would you prefer us to leave our answer in fraction format, like 4 out of 52 times 3 out of 51, or should we convert it to a decimal?
That's a great question. And the answer is, you may not like this or you may like it. The answer is, it depends. So if you are doing the assignments or the quiz from the online chapter assignments, so it's like the chapter 3 assignment, the most important thing is read the instructions. It'll tell you what it wants. So if it says round to 4 decimal places, then you would give 0.0052. Do you see that? If it says write it as a fraction, as a reduced fraction, then actually you would say that would be 3 out of, let's see, 13 times 51, maybe math, but 3 out of whatever. Oh, actually, that wouldn't be so bad. It's 3 out of 13 times 17, 225, 221. I don't expect you to do that in your head, by the way.
Got it. Thank you.
If it is a problem that is from the exam, and thanks for reminding me, even though you didn't even know you were reminding me. This is week 2. And an important thing about week 2 is week two is an even number. Why is that important for this class? Remember? Talked about last week. Okay, if you don't remember,
Is it that
every even number we have an exam. Yeah, so we're in week 2. So by Sunday, you need to do the exam. And I recommend first doing the chapter 3 assignment because the exam covers chapter 3 and chapter 1 and 2. So most of the exam problems, the first bunch of exam problems are exactly, they're literally, I randomly grab from your chapter assignments. Okay, so everyone gets different problems because it's totally random. And then the last few problems are written problems. If it's a written problem and you're asked to do something like this, then show your work in writing. And as long as you show your work, I'll be happy if you write as a fraction, and I'll be happy as you write it as a decimal, as long as it's correct. Sound good? So for the written ones, the key is show your work, and then you can do whatever you like the best. But for the computer graded ones, computers aren't as flexible as people. So you have to do what it says or it zaps you badly. Does that make sense? Hopefully that answers your question. It's a good question. Thank you for reminding me, even though you may not even know you reminded me. We have an exam by Sunday. Exams are a big part of the grade. So if you make like a little mistake on the chapter 3 assignment or chapter 2 assignment, that's not going to zap your grade much at all. And it's not even worth complaining about. What matters is you understand it and you can get it right on the exams. If you make mistakes on the exam, that's a much bigger part of your grade. And the exams are timed. So you have 90 minutes. So make sure you give yourself, from when you start to when it ends, it's a timed exam. Whereas the rest of the assignments are not timed. Where do you see your grades and comments for discussions? Yeah, so the way you see your grades is you go to Canvas and you click on grades. I actually can't do it because it'll show individual grades. I'm not allowed to show like everyone's grades in the class. But you click on grades and then and then you'll get to see your grades. Does that make sense? How many questions on the exams? It's usually like 20-ish, maybe 18, something like that, questions. Okay. And again, Braulio has been through this, and feel free, as he said, to stop by Cranium Cafe. So I'm reading it because Braulio, by the way, the ones watching this on YouTube can't see your chat. So that's why I'm reading it. And he says, feel free to stop by ltcc.craniumcafe.com, craniumcafe.com for help with homework and concepts. I'll be online from 2 p.m. to 7 p.m. That's a lot of hours today. Looking forward to working with you all. Good luck. So that's important. Okay, any other questions? Okay, so now what I want to do is let's look at a harder one. Okay, suppose you pick 5 cards for a poker hand. All right, so now we're going to mix the deck. And then I'm going to pick 1, 2, 3, 4, 5. And there we go. Here's my 5 cards. Okay, I'm not showing you what the cards are, but you can see there's 5 cards in my hand. What is the probability that you got a royal flush? First thing in the chat box, what is a royal flush? See if you know. If you know, that's a poker word, by the way. You don't know what a royal flush is? Yeah, how many questions on the exam? I answered that too. Usually a little less than 20. Every exam's a little bit different. So yeah. So a royal flush, good. 10, Jack, Queen, King, Ace, all the same suit. So what we need to do is we need to write down as a probability. And a probability is a fraction. So that's going to be I want to write it as an equation. There we go. That's going to be a fraction. So make a fraction out of it. And what is a numerator? How many ways are there of getting a royal flush? And what I'm going to do is I'm going to let you know order is not going to matter. We're just going to think about how many unordered ways are there of getting a royal flush. So how many ways are there getting a royal flush? There's 4. Okay. And then how we want to say, well, how many different ways are there of picking 5 cards out of a deck of 52 cards where order doesn't matter? Because if we ignore the order, we have a numerator and denominator that everything will cancel nicely. And you can do what one person sent me, which is very messy. And that is a mathematical full way of doing it. This class is not sophisticated enough for me to fully explain all that stuff. Instead, what we can do is we can go to the calculator menu. Okay, remember, hopefully you always have this one at hand while you're working on stats because we're using it all the time. And we're on number 5, combinations and permutations. As I go in order. We did Z-score last week. That was the last thing that happened. Now we're in combinations and permutations. And we are picking from 52 cards. So I'm going to go 52. And there are 5 cards in a royal flush. I mean, in a poker hand. And we're doing what's called combinations. When order doesn't matter, then combinations that we want, you click combinations. Okay, and it's more than 2.5 million different hands of poker hands you can get. Okay, by the way, the last thing you'd ever want to do is list them all, count them all, because you'd be there for, millions of different writing, and that is brutal. So instead, trust me that I programmed this correctly, which I did, and this is how we do it. So we get 2,598,960 different ways. So I'm going to copy and paste that right in. And there's our probability. Okay. So by the way, is it pretty likely or very unlikely to get a royal flush in just a 5-card poker hand without getting more cards? What do you think? Likely or unlikely? Yeah, it's incredibly unlikely. Okay. It's very, very unlikely. 4 out of 2.3 million tries. Okay. And I want to give you kind of a definition of unlikely. Okay. And this is what's used in statistics. Most of the time, not always, most of the time, if it's less than 5% chance, 0.05 probability, we say it's unlikely. Okay. So that's that's like the standard unlikely word. We'll get into that in a much deeper detail in a few weeks. But today I figured I'd give you a little prelim of what we're going to be doing later. And that is understanding what unlikely is. Any questions on this example? Okay, here comes another example. Okay, so we're asking about the exam or the quiz. Suppose there were 20 questions. Okay, and let's suppose they were all multiple choice questions with 4 choices. Okay, and you have no clue. You have no clue what the answers are. You did no studying and you have no memory. So we want to think about what is the probability of getting all of them correct if you just completely randomly guess. Okay. So this one actually is mathematically a lot easier. And I can definitely see in the direct message, I see someone got it right. But the probability, make it a little bigger. The probability of all correct. I'm going to use the multiplication principle. So I say, what's the probability that the first one is correct? What's the probability you get the first one right? That's supposed to be easy. So you can put in the chat box, you say, what's the probability the first one is right? Yeah, that'll just be 1/4 because there's 4 possibilities. You pick one. That's 1/4. Please stop me if you don't understand something. What's the probability you get the second one right? Two out of 2? That'd be 100% chance of getting the second one right if you just guessed it. Any thoughts on what the probability of the second one is right? Sorry, I'm in the middle of lecture.
Oh, no, I'm sorry.
Yeah.
No worries.
The other stats teacher wanted to know. Yeah, 1/4 again. It doesn't change. And the third one. I hope we can all tell me what the third one's probability is going to be. Yeah, still 1/4. And I'm just going to go ... It's just going to keep going 1/4 every single time. Okay. And knowing one doesn't change. If you got the first one right, that doesn't change your probability of the next one. It doesn't mean anything because you're just guessing each time. And probably the last one will be 1/4. So if you multiply 1/4 times 1/4 times 1/4, and there's 20 of those, that becomes a power. So that's going to be 1/4 to the 20th power. Is that a big number or a small number? Yeah, can you, I'm not sure, I think you can all see. What is Google telling me? That 1/4 to the 20th power, is it 9.09? Is that the probability? Is the probability 9.09? About? Is it close to 9.09? What do you think?
It's 0.000000000000909.
Right, right. And I want to give everybody a major heads up because a very common error people make is not to read the far right. This E negative 13 means times 10 to the negative 13th power, or it means move the decimal over 13 places. Got it? So the first place you move it is just going to be to the left of the 9. And then after that, you're going to have to put a 0 in every time you move. So you're going to have 12 zeros and then the 9 and 09 if you want. So this probability you can have 12 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 909. Okay, which is like absurdly small. Any questions on this example? So I want you to put this in the chat box. And that is, I want you to write down, I will never answer with a number bigger than 1 when asked a probability. Put that in the chat box. I want you to promise it. So put that, everyone just write that in the chat box because I want you to write that out. I don't want anyone to make that mistake. And if you promise in the chat box, you're much less likely to make the mistake. So I will never answer with a number bigger than 1 for a probability. Type that out. I want all of you to write it out because, again, it is a very common mistake, and I don't want you to make that mistake. And if you're watching this on YouTube, write that down on a piece of paper. Again, it'll force you to remember not to do it. Got it? Okay, so I'll be doing this a lot. I'll say, here's a mistake lots of people make, and you don't want to be one of them. And it especially happens because of that way of writing the E negative 13. It's a very common, like people don't look far enough to the right to see what the answer really is. Okay, so hopefully that's good with y'all. Okay, so here's some more stuff. And this is, let me give you the kind of a card example. If I pick a card, and then you can even look at it. You see the card? It's an 8 of clubs. And I put it back in the deck. And then I mix the deck. And I pick a card. What's the probability this card is the 8 of clubs? Yeah, it's 1 out of 52 because this is called with replacement. With replacement means that what you just saw can happen again. That exact item can happen again because I put it back in the deck. Got it? Okay. So if you're allowed to repeat an answer or you're allowed to get the same card the next time, then that's like with replacement. And we say the probability of A and B is now the probability of A times the probability of B when it is with replacement. And we say that these A and B are independent because knowing that we got the 8 of clubs does not tell you anything about the probability the next card will be the 8 of clubs. Any questions on that? And when we did this all correct, that was with replacement. When you made your second guess, if you chose, A for your first guess in the multiple choice, you could choose A for your second guess. Do you see how that works? Okay. So here's another example. See how you do. So you might be able to see, do you know what this is? In my hand? Anyone know? It's a lottery ticket. Okay. In fact, it's Powerball. Okay. And what you may not notice, it's kind of hard to see, but there's 3 lines of numbers because I bought 3. Okay. So if we look at this, the first thing, by the way, if I have a winner, okay, and by the way, today's Tuesday, I'll find out tomorrow, Wednesday, whether I won. I'm going to win $300 million. Okay, I don't mind. Okay, might ruin my life. They say it's not always good to win that kind of money, but hey, I'll take it. So I'm going to be winning $300 million. What is the probability that I'm going to win the big Powerball? Does that make sense? So, like, do you think it's worth it to go and, bring kind of my office with a gun and then steal my ticket? Because then you win $300 million if it's a winning ticket? Yeah, well, if it was a 50-50 chance it's a winning ticket, it might be worth it. Okay. Although, you have to feel bad because you've robbed someone, which is never good, but at least you get 300 million. But the question is it worth the chance? Because, you might win if you rob me of my ticket. So what do we have to do is let's find out how likely it is that I'm going to win. So what I did, and I think it tells you, let's see how to play. Okay. So we're going to pick 5 numbers between 1 and 69 and 1 number between 1 and 26. Just a note, this is an interesting question, and it's actually statistics is involved. Do you think it's smarter to pick your favorite numbers or to let the lottery pick random numbers for you? Which is a smarter strategy? Any of you play the lottery? Which is smarter? Okay, it's actually not, it's tough because there's statistics involved. Okay, it turns out it's smarter to use the machine. Now, if you don't know the rules of the lottery, you wouldn't know. And the reason is that if you pick your favorite numbers, there's a higher chance that your favorite numbers are the same as someone else's favorite numbers. And if 2 people win this lottery, you don't get 300 million, you only get 150 million. So if you do random, then the chance of having the same numbers as someone else is actually smaller than if you pick your favorites. Okay, and it's a psychology thing. So just trust me on that. But there is actually statistical analysis to show that. Okay, so we're going to let a computer randomly pick the numbers. So let's go back. And we're supposed to pick 5 numbers between 1 and 69 and 1 number between 1 and 26. So first thing is, let's write this down. Probability of winning is equal, right, as an equation. We're going to have a fraction. Hopefully you're used to fractions. How many ways are there for me to win? How many ways for winning? Okay, you may think 1, but I told you something. Not 69 either. There's 3 because I told you I bought 3 tickets, 3 sets of numbers on this ticket. So it's actually 3. Okay, so there's 3 ways of me winning. And that is for 1 of my 3 sets of numbers to win. By the way, if you only spend $2 and you buy 1 set of numbers, then it would be a 1 in the numerator. But I bought 3 sets of numbers, so it's a 3. Now the denominator. How many ways are there of picking 5 numbers between 1 and 69? Well, the key is right here. We've already done that. It's just like the card game. So there are 69 numbers. And we're picking 5 of them. So R is still 5. Order doesn't matter. Okay. And if you didn't know that, I'll tell you that's just a lottery thing. That's not statistics. But order doesn't matter. So we're going to calculate CNR. And there we go. Okay. And it looks like around 11 million ways. So let's copy and paste that in. And times, now comes the easy one. How many ways are there to pick one number between 1 and 26? If you think you need a calculator, you're confused. How many ways are there to pick a number between 1 and 26? And that's the power number, by the way. Yeah, there's 26 ways. You have 26 choices. So there's the probability. And let's pop this into good old Google. And there's our denominator. That's such a big number, it's hard to even read. That's our denominator. Did I get the 3 over? Oh, you know what? I think I didn't get the 3 over. That shouldn't be the denominator. I think I put it didn't copied and paste. It didn't give me the over. Over. Parentheses. And parentheses are really important when you're doing calculations, by the way, because the denominator has both the numbers, means you need a parenthesis. Okay. And it's 1.02666, or we could just call it 1. E negative 8, that means there's going to be 7 zeros before that 1. So our probability of me getting that 300 million or winning the lottery, big money, is right here, 0.000000001. And by the way, if you want to see what that is, how to read it, that's when to go 10, 100, 1,000, 10,000, 100,000, a million, 10 million, 100 million. So it's about 1 in 100 million chance that I'm going to be this like super rich person at the end. Okay. By the way, I do this every quarter. Any guess on how many times I have won the big lottery? I've been doing it for like decades. Yeah, 0. Right. Talking about 1 in 100 million chances. Even if you do it 3 times a year for 20 years, that's still almost no chance. So yeah, no, I've never won the lottery. Okay, I have won like $3 or $5 or something like that, but never big. Any questions on the lottery example? Okay. Again, notice that we're not in the example of just like simple picking a card where you just write down how many because you can just count them. There's no way in the world you'd be able to count these out. That's why you have to do the math.
Sorry, I'm a little bit confused. So 5 numbers between 1 and 69, it can be the same number, right? Multiple times?
No.
Oh, okay.
No, when you pick lottery numbers, I'm sorry, I didn't say it, but that's part of playing the lottery. You pick 5 numbers that are different between 1 and 69.
Got it. Thank you.
And sorry, that's not me. That's the lottery. That's just how the lottery works. Yeah. So, and then what they do is they have I think they still do it with balls, but they have big bin of balls that have the numbers from 1 to 69, and literally they pick 5 of them out and they read them. And they don't put them back in. It's not with replacement. Okay, next. Okay, again, today is lots of examples day. There's not a lot of theory, it's all examples, but it's hard. Okay, so maybe I'll make this a little bigger to make it easier for you to read. Okay, suppose that 20% of all students taking stats at LTCC are African Americans, and 40% of all stats students at LTCC are non-STEM majors. Okay, if 22% of LTCC stat students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. Okay, what do you think the hardest part of this whole problem is? Any thoughts? You might have the right idea, sorting out which probabilities to use and how. But honestly, what I think, and it might be what you're thinking too, kind of, is just reading it. It's just reading the sentences and saying, what is it giving you? What is it asking? Okay. And then sorting out the probabilities after reading it. So here's my suggestion for doing these kind of problems, which you're going to see these problems, by the way. The first thing is do exactly what I just did. Read the whole problem, get a good feel, kind of a slight feel for what it is. Does that make sense? Here's the next thing I recommend doing. And that is slowly going back a second time, slowly reading it. And every time it gives a number, write down what that probability represents. And when it has a question, write down what probability is being asked for. So let's start out here. Suppose that 20% of all students taking stats are African Americans. So first thing, as a decimal, what is 20%? That's required, and you want to use decimals, not percentages. That's not a trick question. How do you take 20% and make it a decimal? It's supposed to be pretty easy. Yeah, 0.2. Okay, and that's a probability. Probability, and it's a probability of being African American. What's a good letter for African American? The hint is be nice. Yeah, how about A? So I'm going to use A for African American is equal to 0.2. You could use AA if you want to, just more writing. I'm going for A. Sound good? Now we keep reading. 40% of all stats students at LTCC are non-STEM majors. What's a good letter for non-STEM majors? Okay, I'm going to use capital N because remember I told you lowercase n is the sample size. So it's a little safer to use capital N, just a note. So probability of capital N is equal to 0.4. So do you see how I'm taking the sentences, turning it into symbols, and it's going to be a lot easier to handle. Next one I have to help you with. If 22% of LTCC students, non-STEM majors, are African Americans. Okay, so amongst the non-STEM majors, not all students, but amongst the non-STEM majors, 22% are African Americans. The way I'm going to write that, that's going to be a probability of being an African American. Okay, because 22% are African Americans. But we have changed the population from everyone to just non-STEM majors. The way we write that in symbols, we put a little vertical line segment, and then we write N. And the way we read this is probability of A given N. That's how you read this PA kind of vertical line segment N. Have I lost anyone? So we're given the information that N is true, that we have a non-STEM major. Now find the probability that that person is an African American. Any questions on this example so far? Any questions? Okay, so now let's read the next piece. You pick a randomly selected African American. Okay. All right. If you have to leave early, just a note, you'll watch it on YouTube at the end in not too much longer. I'm going to give you the secret word, but we're not quite there yet. So you can watch on YouTube for that secret word at the end. You can skip the first 55 minutes. Okay, so here we picked a randomly selected African American. Find the probability the student is non-STEM. You'll notice it's kind of backwards, right? Whereas this one was we picked a non-STEM and it gave the probability of being African American. Now we're picking an African American. We want the probability that the person or the student is non-STEM. So our question is the probability of being non-STEM given African American. And I'm going to write equal question mark. It means I don't know. Any questions on that so far? Anyone lost on taking this paragraph and turning it into symbols? Once you have symbols and the formulas, which I'm about to give you another formula, it's actually really easy, but you have to be able to understand how to get the symbols. That's the hardest part. Okay, so here's an important formula. And that is, instead of N and A, I'm going to use kind of the standard. That's the probability of A given B is equal to the probability of A and B divided by the probability of B. I think I'm going to, since we just did red, I think I'm going to put it in another beautiful, important color. How about purple? Okay, so very important is the probability of A given B is equal to the probability of A and B divided by the probability of B. Okay, any questions so far? Is that clear? Okay. Oh, I didn't write down the probability of A given N was 0.22. Because we were 0.22. Because we're told that was the 22%. Any questions so far? Okay, so now we want the probability of N given A. Okay. We don't know that, but here's what we do know. We know probability of A given N is 0.22. Let's I'm going to copy and paste that. But the probability of A given N by our formula is the following. That's the probability of A and B. But in this case, instead of A and B, it's A and N divided by the probability of N. But the probability of N, we know. The probability of N is 0.4. Anyone lost on that? I just plugged in. Is that clear? Okay, so now I'm going to do a little bit of very basic algebra. If you have 0.22 equals something over 0.4, I can multiply left and right by 0.4. And I can say the probability of A and N is equal to 0.22 times 0.4 by multiplying left and right by 0.4. Okay, remember this is a math class, so you're going to see some math. Any questions so far? Let me do the following so that we can read it better. There, now I can read the whole thing on the page. So we want the probability of N given A. Well, the probability of N given A, now I can drop the question mark and just start working it out. That's going to be the probability of N and A, which is the same as the probability of A and N. With and, it doesn't matter whether you read left to right or right to left, divided by the probability of A, which is equal to probability of N and A is the probability of A and N, which is 0.22 got an extra 2 there. 0.22 times 0.4, just plugging in where I had it before. And then I go divided by the probability of A. Probability of A was 0.2. Any questions on that? I think that says comma. It needs to be point. There we go. Any questions? Okay, so now you can put in your calculator if you want. You can do it in your head if you want, whatever works for you. And what do you get? At least when I do it in my head, which may not be right because I did it in my head, but what I get is 0.44. Any questions on the answer to this question, which is the probability of n given A is 0.44. At this point, you might be believing me that this is a hard chapter. Any questions? Okay, if there's no questions, let me move on because we do have stuff to do. Okay, and again, here's the key formulas we just used. I think I'm going to skip this because we only have so much time. Okay, I want to go to contingency tables. So here's an example. Embedded link for the calculator created in the chat. Yeah, so do you want it this one or do you want the general one that has all the calculators? Which calculator do you want? Do you want the specific one or do you want the general one? And if you have this one, you can always click back to the calculator menu. The general one, yeah. So if you click back to the calculator menu, by the way, that gives it to you. And I'll put that in the chat for you. Okay, so because you certainly don't want to memorize it. It's kind of messy. Okay, so now let's do what's called a contingency table. And I'm going to do it by example. It's really the easiest way. Okay, a survey was done asking LTCC transfer students where they plan on transferring to and what living situation they will be in when they transfer. And here's the results. Okay, we have CSU, which means the Cal State University. We have UC, University of California. We have University of Nevada, Reno, which is our closest university, by the way. And then other. And then we have some people are going to live in an apartment. Some people are going to live with their parents. And then some people are going to have other ways of living. Maybe they'll be homeless. Who knows what they'll do. Okay. So first thing I want to make sure you understand how to read this table. Okay. So for example, the number 7 means that of this survey, 7 of these students said that they're going to transfer to University of Nevada, Reno and live with their parents. That's how you read these numbers. Any questions on that? Okay, so we want to find the probability that a randomly selected student will go to a UC campus or live in an apartment. And I gave you a little note, so we don't have to spend a lot of time. There's 246 students. Make this a little bigger so you can see it. So I want to give you first a formula. Today is the day of formulas. I don't know if you've realized that yet. Probability of A or B is equal to the probability of A and B, of A, plus the probability of B, and minus the probability of A and B. Any questions? Any questions on this formula? So it means look at all the A's, look at all the B's, and just you've double counted the ones that are in both. So that's why you have to subtract the both. That's the reason why this formula works. So now we got to figure out, in this case, we want the probability of, notice we want to be a UC campus or apartment. So how about APT for apartment? Well, that's going to be the probability of living in a UC, of going to a UC, plus the probability of moving to an apartment, minus the probability of UC and apartment. Any questions on that? Okay, so now to find these probabilities, let's start with the UC. So remember that to find the probability of something, it's a fraction, right? So I am going to make a fraction. How many UC students are there? Here's our UC group. How many UC students are there? See if you can tell me. Put in the chat box. How many UC students are there? Yeah, 60. 33 plus 8 plus 19, that's 60. How many total students? That's 246. That's given. Plus. So now we do the same thing. We make a fraction. How many apartment students are there? Let's see, use a calculator, you get the head like I did it, whatever it takes. So how many apartment students are there? Yeah, 117, that's what I got to. Which I don't always trust because I did it in my head and I'm pretty good at arithmetic in my head, but not perfect. So I'm glad you got the same thing I was thinking. Okay, still out of 246, that doesn't change. And then minus, next one's actually even easier. How many students are going to transfer to UC and live in an apartment? You don't need a calculator, that's a hint. You just need eyes. Yeah, 33. Still out of 246. And when we work that out, you get 60 plus 117 minus 33. And that is 144 over 246. If I did it in my head right. Any questions at all on this example? So this is called a contingency table. Often you're given a table like that and you got to find some probability. And sometimes if you have an or, you work it out. If you had an and, then it was a real quickie. If you had a given, if I said, what's the probability of someone transferring to UNR given that they're living with their parents, then you would say, well, now we're only looking at the parents because you're given they're living with the parents. And you just say, well, how many are living with their parents? You add those up. That's your denominator. And then 7 is your numerator. That would be how you would do that. Okay, so the next thing to note is a couple very important definitions. And the first one is the following. 2 events are mutually exclusive if the probability of A and B equals 0. Okay, so for example, let's suppose that I asked you 2 survey questions. The first one was, what country were you born in? Okay. And the second was, what city were you born in? Okay, and you probably know the answer to both of those. And if I look at event A being India, so being born in India, and event B was Los Angeles, those are mutually exclusive because the probability of being born in India and Los Angeles would be 0. Because if you were born in India, you could not have been born in Los Angeles. Is that clear to all of you? And that would be mutually exclusive if the probability with the and is 0. Okay, so are transferring to a CSU and living with parents mutually exclusive? So transferring to CSU and living with parents, are they mutually exclusive? Well, take a look. What's the probability of transferring to CSU and living with parents? What is that probability? The idea is you can go probability of CSU and parents. Well, if you look at that, that's 34 over 246. Is that equal to 0? Shouldn't need a calculator to know that, if it is or isn't. Is that 0? Yeah, no. So it's not 0. Only way you're going to get 0 with a fraction is if the numerator is 0. So they are not mutually exclusive. Any questions on that example? Okay, the next big definition is 2 events A and B are independent if any of the 3 are true. And I want to let you know that if one of them is true, the others are true. And that's just a math thing. We don't have time to prove it, but you can trust me. And that is probability of A and B equals the probability of A times the probability of B. Probability of A given B is the probability of A. And the probability of B given A is the probability of B. So if any of those are true, they're all true, and we say the events A and B are independent. If one of them is false, they're all false, and we say A and B are dependent. Any questions on this? Okay, so let's do an example. Are living in an apartment and transferring into UNR independent? So it turns out you can use any of these 3. And what I've found is for this example, the second and third are easier. There's only 2 probabilities in these guys, where there's 3 in these. So maybe I'll use this guy. Let's find the probability of A given B. So probability of an apartment giving UNR. Okay, well, we go up here. How many apartment UNRs are there? 19. Okay, and how many UNRs are there? That's going to be 19 plus 7 is 26, plus 15 is 41. Any questions on that? So 19 over 41. Okay. Then we have to see, is that the same as probability of A, or probability of living in an apartment? Okay. And we actually did the probability of living in an apartment already. That makes life easier for us. That was 117 over 246. What's the easiest way of deciding if two fractions are equal? Do you know? We have these two fractions. If they're equal, then we have independent. If they're not equal, they're dependent. What's the easiest way? If you're allowed a calculator. Anyone know? Yeah, we want to see if they're dependent, but what's the easiest arithmetic way of deciding whether these are equal to each other? Because we want to see if they're equal or not. No? If you don't know, the easiest way is to take the fraction, make it a decimal, and calculators are great for making decimals. There we go. 19 over 41 is 0.463, etc. Any questions on that? And 117 over 246 is 0.476 about. Actually, it's 5 ... and then there's other stuff. Are these equal? .463 and 0.475, are those equal numbers? No, those are not equal. They're different numbers. Equal means the same. So since they're not equal, living in an apartment, I'll try APT, and UNR are independent. Sorry, dependent is what I meant. So if they're not equal, then they're dependent. If they're equal, they're independent. Any idea, any thoughts, any questions on this? Okay, so we are done with chapter 3. There's a lot to talk about. So I want to give you a secret word. And the secret word is fraction, because when you're looking at probabilities, fraction is a key, because it's the total number of ways of the event happening divided by, which makes it a fraction, the total number of ways anything could happen. So that's your secret word. And now what I want to do is move on. So we're not done yet, not even close. Project 1. Okay. Put in the chat box yes or no. Yes, if you have your partners, the partners of 3, hopefully, and no if you don't. Okay, so if you don't, make sure you go to the project discussion board and see if there's anyone else who needs a partner. If you saw one that didn't get replied to, reply saying, please let me be your partner. Or if there's only 2 people that you see together, say, please let me be your partner. Okay. And if you don't find any of those, then post a new reply to the original and say, hey, I'm looking for a partner. Please, please. Got it? So very important to get partners. That's really important. Okay. You can't pass this project without partners. So you have plenty of time, but the longer you wait, the more miserable it's going to be. That's why the hope was you already have them. So I'm going to go to the syllabus, and I want to remind you a few things. First is the project one is due October 23rd. That does not mean you should start on it on October 23rd. In fact, my suggestion is by October 22nd, you've actually submitted your final version and you're done. And then there's no stress. So if your electricity goes out on the 23rd, but you've submitted on the 22nd, you're fine because it's already submitted. So at least a day ahead of time, maybe more if you want. Because again, you're ready now to start getting into it. So that's a big deal. It's 10% of the grades. That's a big, it's a decent part of your grade. Just note that all of the chapter assignments combined equal project one's weight. So we call these, when we have like assignments and discussions where each one is worth very, very little, given that there's 13 assignments. It's not even 1% of the grade. Those are for learning, okay? And whereas the project, it's important for learning too, but that's where the, kind of a big part of your grade comes from. Same with the exams, they're a big part of your grade. So take them very seriously. So take this seriously. If you don't do the project, you pretty much can't get an A in the class, okay? And probably won't even pass because that means that you're the kind of person that doesn't do stuff, and that doesn't work. You need to do all the material, all the work, especially the big stuff. Okay, so that's the first thing. Then it says 2 projects that are created for the class. For project 1, you're going to collect quantitative data. Do you remember the word quantitative? What does that mean? What does quantitative data mean? Countable, probably the right idea. Yeah, numbers is a better word. So it means the answer to the survey question is a number for everybody. So one thing I recommend is asking your partner the survey question. If the partner doesn't have a number as an answer, this project won't work. Got it? Any questions on that? So it's quantitative, very important. Okay, you're going to use a computer to display the charts. Not going to do anything by hand. Okay. And then I want to click on project 1 and we'll talk about all the details, or at least a lot of them. Okay, so here's what you're supposed to do. With you as in y'all, like your group. Think of a quantitative investigation that someone might contract out to have done. Okay. So if nobody would be interested in what you're doing, then it's not a good project. Okay. So you need to identify who might contract it out. You don't actually have to, get a contract, but at least in theory, you have to be able to identify someone who might do that. It might be, President Biden. It doesn't mean you have to talk to Biden. It'd be cool if you could, but good luck. But it doesn't have to, again, you don't have to actually talk to the person, but you could at least imagine the person being interested. Does that make sense? Okay. And, there's lots of different organizations that might be interested in be the head of that organization or type of thing. Okay. Then you're going to perform the investigation. So before you actually do this, let me give you a suggestion. Once you, and you've shared it with your partners, have thought about the quantitative investigation, the next thing you do is think about how you're going to collect your data. You're going to be collecting data. Okay. And I want to let you know the sample size must be greater than 30. So what's the smallest number of people you can get answers from for your survey? What's the smallest number of people you can get answers from to be accepted for this project? Okay, it's not a trick question. Sample size must be greater than 30. That's a big, big hint. That's all you need to know. Yeah, 31. Okay. Okay. Don't ask 20 people. Don't ask 30 people. 31 is fine. 40 is fine. How about 50,000? Do you think that's fine? What do you think? How about 50,000 people? I'm looking, not seeing answers. Okay, the answer is that's in theory, it's fine. In practice, it's not, because no one is going to have time to ask 50,000 people a survey question. Got it? Typically, it's between 31 and 50 people. That's typically what you get. You know, sometimes 31 is fine. Sometimes a little bit more. If there's 3 of you, and it's 33, so you can like each ask 11. Does that make sense? Because remember, if there's 3 in your group, then 11 each. If there's 2, then you're gonna have to do like 16 each. It's more work. So that's why I recommend 3 people, less work. Any questions on the sample size and all that? Okay, so you must either use simple random sampling, stratified sampling, or cluster sampling. Okay. By the way, simple random sampling, do you remember what I said about that in terms of in practice? Of doing a simple random sample in the real world? Remember? If you don't remember, let me tell you, it's almost always impossible. So I didn't even give you a link to it because theoretically you're allowed to, but good luck. It pretty much can't happen. Stratified sampling and cluster sampling, those are your basic 2 choices. And we talked about that last week. You can look at that video. You can also click on either of these links to get a reminder of these 2 sampling techniques. But that's what pretty much everyone uses, is stratified or cluster. Got it? All right, so here's my suggestion. Within the next 7 days, you get together with your partners, talk about it, come up with an idea, come up with what your survey question is going to be, and come up with how you're going to collect your data. Got it? And again, it has to be a survey question of people. You need to ask people. Okay. Okay. Now, if you have COVID, you're allowed to ask online. I don't want anyone to give anyone else COVID, but it needs to be a people survey. Got it? Okay. And it has to either be stratified or cluster. Come up with your plan. Then once you have your plan, here's what you should do. You should go to the discussion board. You should go to the Project One discussion forum. And you should hit reply and write out what your plan is. Write out what your survey question is going to be. Write out what your population is going to be, maybe who your client is. Okay, and that's in theory the client. And then write out how you plan on conducting the survey. Okay, physically. Any questions on that? Why do you think it's a good idea to write it up here? See, hit reply. I'm not going to write mine because I don't have a plan, but because I'm not doing it. Yeah, get feedback and I'll give you feedback. Okay. And that way, sometimes I'll say, you have a great idea, but reword your question in a slight way because that way people will understand it better. Or I'll say, what you're using is really convenience sampling. So you might want to try this to make it truly stratified or something like that. But I'll give you some feedback, or maybe I'll say, wonderful, everything looks great. Go ahead. I'm looking forward to reading your paper. Got it? But this way you don't make a disastrous error because you spend some time doing the survey, and if it doesn't work, then all of a sudden you don't have a study anymore. I might even say, hey, your survey isn't quantitative and this won't work. You need to come up with a new one. Okay, because it has to be quantitative. So those are typical things that I often have to tell people. So do that. And I recommend like have that done in the next 7 days or so. Again, it doesn't take that long to come up with a plan. Okay, so once you have a plan and once I've told you it's great, then what you're going to do is you're going to do the survey. Okay, I do have a few rules. Okay, and they're, believe it or not, they're legal rules. So the first one is you are not allowed to ask anybody under 18 years old unless they're a Lake Tahoe Community College student. Okay, do not go to a high school and ask kids. Okay, do you know why? It's not because I hate kids, by the way. Yeah, it's against the law. Okay, and not only that, I am recording this. It's going to be on YouTube. So when the lawyer comes and tries to sue me, I could say, I told my students, and here it is on YouTube. Don't do it because you don't want to get sued. Okay, so do not ask children. Got it? Okay. If you are asking people in a business, like say at Safeway supermarket, then make sure you go to the manager and ask the manager if it's okay to ask that. I strongly recommend say, you know, I'm in a really hard statistics class and we have to do a survey. Is it okay if I go and ask, you know, 10, 12 people in this market, you know, in the supermarket, or 35 people, you know, whatever you're doing for that market? They'll always say yes, but ask first. Okay, especially if you're working there, by the way. Okay, especially if you're working there because you don't want to get fired. Okay, but even if you're not, it's always better so you don't get in trouble. Got it? Okay, so if you're going to a business, ask the manager, make sure it's okay. They almost always say yes, but you should always ask. Okay, similarly, if you're going to be asking students in a Lake Tahoe Community College class, ask the instructor for permission. They almost always say it's fine, but you need to ask. Okay, and again, that you won't get sued, but it's just the wrong thing to do. To like not ask. Got it? Okay, so those are just a few things that I require in terms of the kind of the legality stuff, is ask for permission and those kind of things. Got it? Okay, if you can ask your friends, you don't have to ask for permission for anything. Okay, but again, that could be convenience sampling, so be careful. All right, so then you conduct your study, you survey, and again, you should have, you know, let's say your sample size is 33, you should have 33 numbers written down. Got it? Okay, and just to let you know, it's just a list of 33 numbers. If you're doing stratified sampling, let's say you were doing by gender, where you had male, female, and other, then even though you're going to have a bunch of males, a bunch of females, and maybe a few others, you still have 33 numbers written down. The male, female, other thing is just so that you can prevent bias. Got it? Any questions on that? Okay, in terms of the data collection, once you've collected your data, you're just going to have one row or one column of numbers, and that's it. You're not doing a comparison study, because that's another thing that people make mistakes on. Any questions on that so far? Okay, so now you have your data. The next thing you do with your data is, any guess? Any guess on your next step? Once you've collected your data and you got a piece of paper with your, say, 33 data values. The hint is it's not that hard. Let's see, I'll jump it in. You click on Project Spreadsheet Resources. Click on Google Sheet Statistics package written by Larry Green. Okay. And just a note, this is the link you want right here. These are a bunch of instructions on how to use it in case you're confused, but this is really the link here. And that's my sharing link. Any questions so far? And I showed this to you last week, but just want to make sure. Then once you do that, you go to File. Then you go to Make a Copy. Give it a name. Okay. And then hit Make a Copy. I don't need a copy, so I'm not going to do it, but you're going to need to do that. Once you have your copy, then you can share it with each other. That's one good thing about Google Sheets. You're not allowed to use the regular calculator that I created. You have to use a spreadsheet. And as I mentioned, I think in the orientation, that way, when I get a phone call from the department that you might be transferring to, I say that yes, spreadsheet was required, and they use a spreadsheet. And then this is much more likely to transfer. And that's number one. It would suck if this class did not transfer for you. But if you wanted to transfer as a general education statistics class, by making this happen, every college says yes. Okay. If this doesn't happen, a lot of colleges say no. Okay. If you want this to work for your master's degree, this may not work because sometimes they need some upper division thing. But but sometimes it does. Just a note. Okay. Then what you do is, what I would do is highlight the numbers that are in here, and there might be different numbers, hit the backspace, and that starts it out with new numbers. Then you type in the numbers. Okay, so that might be, I'm just going to make up some numbers, say 4, 5, 23, 18, 55, 37, etc. Now, you can have more than 6 numbers, but I don't want to waste your time. You're going to have over 30 numbers, like at least 31. Okay, and you'll notice that all you have to do for most of it is move your eyeballs. You all know how to move eyeballs, I hope. And you'll see all the statistics that you need for the project are here, and a lot more too. So just because it's here doesn't mean it's in your project. You're only going to do the ones that we've already learned. So minimum, mean, variance we don't really do with. Sample standard deviation, that's an important one. Median, maximum, Q3, and sample size. Q1 we use, got it? Okay, most of these others we don't use. IQR maybe. Another one that we use is Z-score. Do not use whatever numbers here for your Z-score. You're going to use an interesting number for you. So for example, if your survey was, how do you find the sheet again? You go to this project page. Oh, you get, sorry, the syllabus, you go to project 1. There's a few other ways of doing it too. You go to project spreadsheet resources. You click on this first link and then click on this starting out link. And that's how you find it. Okay. Okay, so notice there's a lot of things to get a Z-score. You're going to change your X value. So for example, if you asked how many hours of sleep people get, you might want to look at 8 because that's an interesting one. And then it'll give you the Z-score for 8 hours, and you'll notice that that was negative 0.79. So that would mean that it's not an outlier. Outliers are less than -2 or greater than 2. Extreme outliers are less than -3 or greater than -3. So it's not, definitely not an outlier. It's certainly not extreme outlier. It's below the mean because we have a negative value, but not uncommon. Okay. If you want to find out, let's say if you want to find out if the number 55 is an outlier, because that was your maximum, then you change your X value to 55. Hit enter. And in this case, it's not 1.6 about. It's not bigger than 2. So definitely look at your max and min, see if you have outliers. And if you have an outlier, look at the next lowest or the next highest. See if that's an outlier until you don't have one. And then you can identify your outliers. Any questions on that? Notice you have a histogram so you can look at the shape of the distribution. By the way, does this look like a normal distribution? No, this does not look like a normal distribution. This is a skewed right distribution. Those are the kind of things you have to talk about on your project and then how your client is going to use it. Any questions on that? I created the ability to do box plot and stem and leaf. When you do box plot, you're going to get all these warnings about possible viruses and stuff. I promise there's no virus. So click OK, I accept it, ignore the warning. And it still may not let you. And then that's why I actually have some extra buttons that are a little harder to use. This one just does it for you. There's your box plot. Okay, and similarly, stem and leaf. If I click on stem and leaf, it'll give you warnings possibly. And there's the stem and leaf. Okay, notice I use the tens digit for the stem and leaf. If you want to use the hundreds digit instead, for example, then you'll see this S and L left 10 power. And if you want hundreds, make it a 2 instead of a 1. Thousands, you make it a 3. Okay. Any questions at all on using the spreadsheet? Okay, you need to copy and paste this part of the spreadsheet. So you just go like that, hit Control C for copy, or if you have a Mac, I don't know what copy is, but I know there's a way, and then paste it into your paper, into your project. Got it? That's required to prove that you use the spreadsheet. You have to show it. You also have to copy and paste your charts. So again, Control copy, and same thing with these charts. And if you don't know how to copy this one, you can always use a screen capture and make a picture out of it and then put it into your project and copy and paste all of your diagrams. Okay, let's go back. We're almost done because I like to finish by 45 after, and we're at 43. So let's go to, where are we? Here we are. So we only have a minute or two left and I'll be done. Okay, so important things throughout the entire paper. Talk about the decisions that your client will make based on that item. So if you're talking about the mean, what the decision will the client make based on the mean? If you're talking about the first quartile, what decision will they make based on the first quartile? If you're talking about the stem and leaf diagram, from looking at the stem and leaf diagram, what decisions will your client make? The box plot, what decisions will the client make? And remember, the most important thing in the box plot is the box. That's the middle 50% group. Okay, so throughout your whole paper, like every paragraph should have decisions the client is going to make or that you're going to recommend the client makes after seeing that data, after seeing that statistic, after seeing that chart. Any questions on that? Okay. You should have, it is a paper, so you should have an introduction, a body, and a conclusion. That's important. Okay. And in your conclusion, you should talk about the main highlights. Just to note, standard deviation, as I mentioned last week, is the most important of all of the statistics. And let me write this. Let me show you. A project without at least a full paragraph devoted to the standard deviation cannot receive an A grade. Just to note, Z-score is about the standard deviation. Chebyshev or the empirical rule is about the standard deviation. The standard deviation is about the standard deviation. As an example format, I purposely don't give you an example because when I used to do that, people just copied and pasted it and it was never very good. Okay, but here's what you should do. It's not going to say on the syllabus, so let me show it to you. So it says, Larry will be happy to look at a rough draft of your paper if you can bring it or email it to him by at least Thursday at 8 a.m. before it is due. I recommend earlier. I will it's first come, first read. So if I get, 5 different example rough drafts on, Thursday, and you send yours, 5 different rough drafts, you send it at 7:59 a.m., yours is gonna be the last to look at because you sent it last. Does that make sense? So Wednesday is better than Thursday, for example, because then you'll get feedback right away, much earlier. That makes sense because it takes me a long time to read it and give you feedback. I got to do that. And usually it takes, an hour or so just for each one. Okay, so just note, do that and I'll give you feedback on whether it works. Also, if you have questions about it, when you're thinking of even writing the rough draft, what should you do? If you're confused about something or not sure how something should look and want to get help on the standard deviation or whatever, what should you do? Any thoughts? Not seeing it. You should ask, but even more important, post your question on the Project One discussion board. And the reason why you should post it there instead of ask me email wise is that way everyone can see my feedback and you can read other people's question and my feedback and you'll get a really good idea of what works and doesn't work. So that's why I want you to do it on the project discussion board. Okay. Okay, so I'm going to let you read through all this. This is again, it's very easy to go from Canvas and see, and you can read through this whole thing. But I think I want to call it, it's actually later than I usually like to go, but the kind of, usually it goes longer when I'm talking about the project. There's another project, or those are the 2 longest probably of the webinars. There'll be one just before Project One, Project 2 also, and or like 3 or 4 weeks before that one. So, but I'll be around, I'll be looking at the Q&A. I'll also be happy to answer questions now. I'm going to stop the share. And I'm going to stop the recording.